In this lesson, we will review a Jupyter notebook to interact with a relational database well known to the data science community. Before we do that, let's spend a few minutes reviewing what we mean when we say relational data model and how to interact with relational data. By the end of this video, you should be able to describe the structural components of a relational data model, demonstrate which components make up a data model schema, explain the purpose of primary and foreign keys, and describe a join operation. The primary data structure for a relational model is a table, like the one shown here for a toy application. You might have also noticed that table structure is very similar to a Python data frame. Data frames can be used to load relational tables, which are also called relations. This table actually represents a set of tuples. This is a relational tuple represented as a row in the table. We were informally calling this a record before, but now we call it a tuple. Thus, this relation is a set of 6 tuples. There are 6 rows and 6 tuples. Remember the definition of sets. It's a collection of distinct elements of the same type. That means I cannot add the red record at the end of this table as a tuple into this relation, because if I do, it will be introducing a duplicate. In practice, many systems will allow duplicate tuples in a relation, but mechanisms are provided to prevent duplicate entries if the user so chooses. Here is another tuple I cannot add. The red tuple on the bottom has all the right pieces of information, but it is all in the wrong order. So this tuple is dissimilar with the other 6 tuples in the relation. Okay. How does the system know that this tuple is different? This brings our attention to the first row, that is the header of this table, painted in black. This row is part of the schema of the table. These are our columns in a pandas data frame. The schema in a relational table can also specify keys. The first column says that ID is a primary key. This means it's a unique for each employee. And for every employee, knowing the primary key for an employee, we also uniquely know the other 5 attributes for that employee, like first name, last name, department, title, and salary. You should now see that a table with a primary key logically implies that the table cannot have a duplicate record, because if we do, it will violate the uniqueness constraint associated with the primary key. I will call our first table employees with the ID as the primary key. Let us now introduce a new table containing the salary history of employees. The employees are identified by the column employee ID, EMP ID, but these are not new values that this table happens to have. They are the same IDs that are present in the ID column of the employees table presented earlier. This is reflected in the statement made on the right. The term references means the values in this column can exist only if the same values appear in employees, the table being referenced. This table is also called the parent table. In the terminology of the relational model, the EMP ID column of the EMP salaries table is called a foreign key that refers to the primary key of the employees table. Note that EMP ID is not a primary key in the EMP salaries table because it has multiple tuples with the same EMP IDs reflecting the salary of the employee at different times. You may remember join as an operation we discussed as a part of pandas. Here's an example of a relational join performed on the first 3 columns of employee and the EMP salaries table, where employees.id and the emp ID columns are matched for equality. The output table shows all columns involved. The common column is represented only once. This form of join is called a natural join. It is important to understand that join is one of the most expensive, that is time and space consuming operations. As data becomes larger and the tables contains hundreds of millions of tuples, the join operation can easily become a bottleneck in a larger analytical application. So for data science that involves big data, when we need joins, it's very important to choose a suitable data management platform that makes this operation efficient. As a summary, the relational model provides a way to describe unique relationships between entities in data records, including the relationships between record identifiers. Pandas data frames implement some features from the relational data model, making it easier to work with relational databases.